dear friends, today we will be discussing more about class members. As we know that class members constitute data members as well as member functions. Let's start with data members. Data members are those variables that describe the characteristics of the class and are declared inside the class. They can have any type like int, float, char, array, enumerated, etc. Their visibility can be public, private or protected. By default, they are private. They are accessible through member function of same class only or through friend function. Public data member can be accessed by their objects also. Constant data member. They can be declared as constant in situations where data has to be fixed. For example, if the cost of mangoes is fixed as 25.50, then we can define class as this is the main program. Here, mangoes are declared as object of class fruits. Can you guess which of these statements are correct? Yes, you are right, only the first one. As quantity is public but color is private and price is constant, so we cannot assign a value to them. Member functions. We have just learned how to declare and access data members. Now we will be discussing more about member functions in detail. Member function depicts the behavior of member data in a class. This behavior may be in the form of services provided by the class or methods, operations available on the data in class. That is why these are known as services or methods. These functions are declared inside the class, but it is optional to define them inside the class. They can be private, public or protected. By default, they are public. Only member function of class can access the private data members and private member functions. Public member functions are accessible from outside the class, while private member functions are accessible from within the class. They have to be declared and defined before use, as in case of simple functions. A member function can call another member function without using dot operator. Member function definition. The class member function describe how the class functions are implemented. The syntax is as shown. The definition of a member function is within the scope of its enclosing class. The body of a member function is analyzed after the class declaration so that members of that class can be used in the member function body, even if the member function definition appears before the declaration of that member in the class member list. There are two ways of defining the class member functions. First, inside the class definition. Second, outside the class definition. Inside the class definition. By this method, member functions are simply defined inside the class. When the function is defined inside the class, they are treated as inline function. That means it follows all the restriction and limitation that are applied on inline function. A member function that is defined inside its class member list is called an inline member function. This is a program to multiply three numbers. This is inline member function multi. When the function multi is called in the following example, the data members A, B and C can be used in the body of multi. The second method is defining a function outside the class. When a member function is defined outside the class, its method of declaration and definition are just like that of simple function. The only difference is that name of the function is preceded by class name. The syntax is as shown on the screen. The class name shows that the function name is the member of the class specified by class name. The scope resolution operator is used to attach function definition to the class name. Inline member function outside the class. An equivalent way to declare an inline member function outside the class to declare it using the inline keyword. Let's take an example. The inline specifier does not affect the linkage of a member or non-member function. That means linkage is external by default. Let's take another example of writing a simple program that accepts model number and price of a bike and then displays them. For this, a class bike is defined with model and price as private int type data member. Enter data and display are function declarations. This function definition defines how to accept model number and price of a bike. This function definition defines the display services provided by the class. In the above example, we have seen that membership label will resolve member function identity and scope when several different classes uses the same function name. This is the preferred style of defining member functions as it is inconsistent with general principle of data hiding. In fact, the definitions are often put in separate files and compiled separately, because application programs only need to know what a class can do without bothering how it is done. Member functions of local classes. Member functions of a local class must be defined within their class definition. As a result, member functions of a local class are implicitly inline functions. These inline member functions have no linkage. Nested member functions. The behavior of nested member functions same as that of simple nested functions. The only condition is that all the nested member functions have to be declared beforehand. In such cases, member function can be called by its name only inside another member function of the same class. For example, a program to find the average of two numbers. This is a class with A, B and C as data members and getData, displayLat and average as member functions. This is the definition of member function getData to input the values of A and B. This is the definition of member function display to input the values of A and B. It also calls a member function average, that is AVG. Have you noticed that it is calling AVG function without scope or dot? This is the definition of member function AVG to calculate average of A and B and return it through class. Constant member function. In certain situations, member functions do not alter any data during the execution of a program. In such cases, we can declare these member functions as constant member functions. They can be declared either inside a class or outside a class. For example, here const function declared and defined inside the class. If const function has to be declared outside the class, then class will be written as here const function, that is constant function declared only inside the class. Constant function declared outside the class. Here ICF is defined inside the class while OCF is defined outside the class. Some of the characteristics of constant member functions are: first, It can't change any data member of the class object. Second, it can't invoke any non-constant member function of the class object. Third, a constant member function can't change the class object for which it is called. Fourth, only constant object can invoke a constant member function. Fifth, two member functions that differ only by the constant qualifier are considered as overloaded. With this, I think you are very much confident with member functions. Static class members. Use of static class data. Why do you want to have a static data? Suppose we have a swimming championship. There are number of swimmers participating for competition. Each swimmer is an object for same swimming class. Now suppose any of the swimmers wants to know how many other swimmers are still there in the race. Technically, we can say that if an object wants to know how many other objects of its class were in the program. In such cases, a static variable count is included as a member of a class. All the objects will have access to this variable, which will have same value for all objects. Static class members. The members of a class can be declared as static. Static class members cannot change. There may be static data members and static member function. One cannot have static and non-static member functions with the same names and the same number and type of arguments. Static data members. Static data members are those data members which are globally available for all the objects of that class and used to maintain the value common to the entire class. One copy of this data member exists in the class and shared by all the objects of that class. It is visible only within the class, that is, its lifetime is the entire program. Static data members are declared inside the class but are defined outside the class definition. The syntax is as shown. By default, static data member will be initiated to 0 at the time of object creation, but they can be initialized to any value during declaration also. Member allocation for static data member. Different objects of same class will be allotted same member space as static data member maintains a common value for its class objects. Static member function is a member function that accesses only the static data members declared in the same class. These functions can be invoked by using the class name instead of using the objects as is shown. Like static data members, one may access a static member function of a class without using an object of class. A static member function cannot be declared with the keywords virtual, constant, volatile or constant volatile. A static member function can access only the names of static members, enumerators and nested types of the class in which it is declared. They cannot access non-static members of the same class or a friend function. Their syntax is as shown. For example, this program counts the number of objects created for a class. After including required header files, this is the static data member declaration which maintains the number of objects created. This is the static member function which displays the number of objects created till that moment. This is the definition of static data member. They are initialized to 0 at the time of object creation. The main program is as here count is incremented twice when put count is invoked and displayed when static function getCount is invoked. C3 is the third object created and functions are invoked, then count is again incremented. The sample output is as shown. So, have you noticed how significant class members are? Okay, see you next time. Thank you.